Okay, so first things first, we need to squat down. Now we need to talk about what the air is. So all this stuff that we're swimming about in, the birds are flying around in, is actually a mixture of things. It's not air. It's kind of like saying dirt, right? There's actually a lot of components to it. So I'm going to go through a couple of components right now. Most of it is nitrogen gas, N2 gas. Now that's going to play a role in our nitrogen cycle. It's going to be part of the transportation sector and everything else, which we've already talked about. A smaller percentage of it is oxygen. Now these percentages are changed, and I'm going to talk about why in just a second. Now, kind of a hot button issue is the percentage of carbon dioxide. So this carbon dioxide, when I drew this model on my back wall here, then the percentage was 0.038. Now, not even that much longer in the future, as of 2019, it's 0.041. That's measurable, that's attainable, that's a hard fact. We know, even in my teaching career, in just the short period of time that I've been teaching AP Environmental Science, then the CO2 concentration has gone up, proven. And it's 2020 as of right now, and we're almost done with it. So that number will be higher even when I teach this lesson in 2021. So at this percentage, because percentage is per 100, right? So these numbers are slightly different as well because this percentage has gone up. So these percentages will be slightly different as well. Now there's some other trace gases. There's loads of other trace gases such as methane, CH4, which is also a greenhouse gas. There's also H2O sub G, which is the gas form of water, which is also a greenhouse gas. So when we get into greenhouse gases, don't think that this is all there is. This is what would fit on my back cabinet, okay? This is the lion's share of it, if you will. But there are other trace gases that do make a huge difference in our climate, in our wind patterns and everything else, and what we experience here on Earth. Now, if you'll adjust that, let's talk about our first layer. Now, this is down here. This is you. This is you down here in your high school. You're in the troposphere. Most of what you think of the atmosphere is actually the troposphere. Hurricanes, tornadoes, climate, our biogeochemical cycling, like the gaseous form of the carbon cycle, the gas form of the nitrogen cycle, the gas form of the water cycle, all that happens here in the troposphere. All of our weather events and everything else happens here. Our pollution, for the most part, happens here. Now, when we get up here into the stratosphere, that's where we start talking about ozone depletion. This is where our ozone layer is. And that's in this equation here. That's not the specific focus of this lesson. It's mostly, I'm telling you that the layers are here, but when you start learning about the depletion of the ozone layer and CFCs, that's happening up here in the stratosphere. The next is the mesosphere. You'll see that the temperature is decreasing. And then you get up here into the thermosphere, what people used to call the ionosphere. Good?
Yeah, no.
All right, we get up here into the thermosphere, or some people call it the ionosphere, and then there's all sorts of really, really intense solar radiation, all sorts of crazy chemical reactions, and there's no way you could live up here because the air particles are like a meter apart. So don't worry about that. As you see, this is an arrow going through here. Elevation is going up, so up there is space, down there is the ground, and this line is average temperature. So what you're seeing here is that as I go up through the layers, what delineates the layers? Temperature breaks. That's how we've decided where those layers are, is these huge temperature fluctuations. So there you have it. That's the layers of the atmosphere and the real basics of what goes on there. Now, that means that we need to continue to work on depletion of the ozone layer, pollution in the troposphere, and kind of what we're working on right now is things like Hadley cells, jet stream, global climate patterns, and things like that. Some of this is natural, some of it isn't. Let me say that again. Some of this is natural, some of it isn't. Hadley cells, polar cells, Ferrel cells, those are all totally natural. Jet streams, weather patterns, El Nino, La Nina, those are all normal events. Do they affect mankind? Yeah, totally they do. Just like hurricanes and tornadoes affect mankind, but they're natural events. However, there are also unnatural things going on, like CFCs, depletion of the ozone layer, our pollution and everything else, and the warming climate, that raising CO2 level.